Welcome back, guys, to the next lesson. We are on 11.3. We're reviewing the lesson about quadrilaterals. And just like the last two lessons, it was all about memorization and understanding the properties of the different shapes so we can classify them and compare them. So, this next lesson is quadrilaterals, and the EQ is how can you classify and compare quadrilaterals? Well, what is a quadrilateral? Well, we learned about that in the previous lesson. And if you look at the beginning of that word, quad means four. So the four-sided shape, four-sided polygon. So if we look at I'm not going to focus too much on the problem, but that was talking about the how many different quadrilaterals can we see? And before we do that, we can come back to that later, because let's review the different kinds of quadrilaterals. So this one, I remember the class having a lot of confusion because it can get a little tricky, because for things like triangles from the last lesson, it's pretty easy because there were only three different ways that you can distinguish them based off the sides. Like either they're all the same, two are the same, or none of them are the same. But this one's going to be a little more tricky, but we had that poster, that our anchor chart in our classroom, which we're going to go over in this lesson, the one that I blew up and put on our wall. But we'll go over that in a minute. But let's look at the first one. A general quadrilateral, general one, has four sides and four angles. So if we could see 1, 2, 3, 4. Four sides makes it a quadrilateral. If it had three sides, be a triangle. Five sides, be a pentagon. We're only talking about four-sided. Okay, but just because there's four sides doesn't mean that it's that simple. Okay, if we go down to a rectangle, okay, rectangle, and this is where we were talking about, well, this can be that, but that sometimes can't be that. Okay, that's where it gets confusing, where it can fall into certain categories and be something, but it might not be something else. It gets kind of confusing, but the chart really helps it out. So rectangle is a special parallelogram. What does that word mean? Parallelogram. And of course, this thing always pops up. Parallelogram, just like parallel, well, opposite sides are parallel. And if you notice the tick marks, we should all be very familiar with those tick marks. This one has one, that one has one. That means that they are congruent. That means they're the same. And go away. Sorry about that. So parallelogram with blank right angles. Well, how many right angles are there? 1, 2, 3, 4. How do we know those are right angles? Well, they have the little square there. So a parallelogram with 4 right angles and 4 pairs of blank sides. Well, what kind of sides? Well, they are not all congruent, but they are all parallel sides. If we look down at a square, okay, a square should be pretty easy, right? All sides are congruent, 4 congruent sides, and blank right angles. Well, we can see the squares, and that one's pretty straightforward. Square has 4 congruent sides, meaning they're all the same length. They're all parallel, or opposite sides are parallel, and all angles are right angles. That was the easy one. Parallelogram. Parallelogram has opposite blank that are parallel, opposite sides that are parallel. Okay, so difference between a parallelogram and a rectangle, because you might say, well, a rectangle, all opposite sides are parallel. And that's the case for this one. Opposite sides are parallel. But if you look at the angles, we have 2 obtuse angles, and then we have 2 acute angles. They're not right angles, so that's why it is not a rectangle. Okay, rhombus. Rhombus is a special parallelogram with blank congruent sides. Okay. So a rhombus is a special parallelogram with blank congruent sides. Some people might confuse this, or might like to call it a diamond. And I guess you could call it a diamond, But for right now, just classify it as a rhombus, meaning, well, all sides, opposite sides are parallel. And what do you notice about the sides on this one compared to the parallelogram? And if you said, well, all sides are congruent, then you're correct. Okay, all sides are the same length. We could tell by that one tick mark. So this is where we could say, well, a rhombus is technically a parallelogram, but can a parallelogram be a rhombus? And that's where we would say no, because a parallelogram, opposite sides are parallel. But a rhombus, in order for it to be a rhombus, all the sides need to be the same length. So these two sides are different than these two sides. And then we have a trapezoid. Trapezoid is a quadrilateral with exactly one pair of blank sides. What could that be? For those of you that don't remember, just take a look at that shape. This is a trapezoid. One pair of blank sides. What can we infer about these sides? What can we say? I'll give you a minute to think about it, or pause the video if you need to think about it. What can we say about the sides, or one pair of the sides? And if you said one pair of parallel sides, then you are correct, because look at these ones. That one is parallel to that one, making this what? This one happens to have a right angle. Okay, but one pair of parallel sides. Okay. And if we go to that chart, this was the chart, the confusing chart that I know it took a lot of people a long time to kind of have that set in your mind. And this right here, like I said, Go Math kind of over scaffolds sometimes, and I think that is a bit much, and that was what was confusing everybody, so we decided not to use that. So I'm going to kind of move that out of the way, or zoom in more. And let's see if we zoom in. There we go. Okay, so on your own, I want you to draw out this diagram. Okay, let's draw it out on a blank piece of paper. You need two big circles, and then in the first big circle, you need two other ones that overlap, and label it. This one's going to be the parallelograms. This one's going to be the rhombuses, squares in the middle, and rectangles, and then at the bottom, trapezoids. And if you notice on the whole paper, what you could put as the title is quadrilaterals, because this lesson is about quadrilaterals, but there are different subcategories that all these different classifications fall under. So I'm going to pause it, and I want you to try to draw, or I want you to pause it, and I want you to try to draw the different shapes that fall in here. And if you could think back to how we did it in class, because we did it together in class, I want you to think about how we classified them. Okay. And I'll go ahead and show you. If you haven't paused, pause the video and try to label them. If you really can't do it, then okay, we'll go ahead and pull it up. So here it is, completely filled in. So we have quadrilaterals, the big picture, what we're talking about. These are all four-sided figures that connect. Okay, they're all polygons, and this one happens to be a quadrilateral, four sides. The first one, we have parallelograms. Well, in order for it to fall under this side, they all have to be parallelograms, meaning opposite sides are parallel. Okay, so if we look right here, opposite sides are parallel. Opposite sides are parallel. Okay, those are parallelograms. But if we go even deeper, well, what could be a parallelogram and also rhombus is right here. We have the rhombuses. Rhombuses can be a parallelogram. What's the difference between a rhombus and a parallelogram again? And if you said, well, a rhombus, all sides are the same. All sides are congruent. If we can, I know on my chart, I labeled it a little more detailed. I put the little tick marks on there, I believe. So I would have one tick mark on all sides. But this one right here, we'd have one tick mark on opposite sides and then two tick marks on the other ones. Okay. So you can see a rhombus is under the parallelogram category, but a parallelogram is not necessarily a rhombus all the time. And then we have rectangle over here. Okay, what's the difference between a rectangle and a parallelogram, or a rectangle and a rhombus? Well, rectangle, opposite sides are parallel, but we have 4 right angles. 4 right angles. No right angles here, no right angles here. And then what overlaps between both rhombus and rectangles is the square. A square is like a rhombus because all sides are the same. But it's different because what does it have? What kind of angles? Well, it's got right angles, similar to the rectangle. But the difference between a square and a rectangle is that, well, look at the sides. They're all the same. Rectangle, only opposite sides are the same. And then down here we have the trapezoids. And the one thing that you got to remember about trapezoids is that there is one pair of sides that are parallel. Okay, so we can take any of these shapes here, we could turn them around all we want, but it doesn't matter which way we turn it, which way we look at it, one pair is always going to be parallel. This one right here might be longer than this one, but they are still parallel. This one right here, parallel. And if you notice, you could have 2 different types of trapezoids. You can have the one trapezoid like this with no right angle, and then you could have this one right here with a right angle. Doesn't matter, they're both trapezoids. But if it said which trapezoid has a right angle, well, of course, then you would pick this one. And then off here in no man's land, we got these 2 oddball shapes that don't fall under any of these categories. They're not parallelograms, they're not rhombuses, they're not rectangles, squares, or trapezoids because they don't have any of those features. The only thing that they have in common with those other shapes is that they have 1, 2, 3, 4 sides. That's it. That's it. And similar to the previous lesson, a good way that you can study it, I know that a lot of you guys took home your Go Math books, but if you want to review these, you still have the gray pages that you could review. You have the online stuff that I assigned on Think Central to do. I know that about 8 people have done almost all of them. Still have quite a few of you that have not completed it, but if you want more practice, I can attach a link with these different shapes on them, and you can cut them out, post them over the room, and then do the same gallery walk where you label them, you draw it, you talk about the features, and ultimately you can, and if we go back to the EQ, and it's not popping up, let's see. Oh, I think I passed it. Sorry, it's messing up. But the EQ, which is classify and compare quadrilaterals using their properties. If you have any questions at all, let me know. Post them in the comments below this video, or post them on Teams in the category where I told you guys to post it. If we go back to that, right here. Wait, no, it's right here. Okay, under the post them in this thread below, and I will get notified. Okay. Well, that's it for this video. If you have any questions, like I said, put them in the comments. Otherwise, I will see you guys next time.